Hi guys, this is Geometry, Lesson 5-3. We're going to look at medians and altitudes. In this lesson, you'll be able to find the points of concurrency for the medians of a triangle and the altitudes of a triangle. Some vocabularies we're going to use are altitude, centroid, median, and orthocenter. Remember, we talked about circumcenter, inscribed circles, incenter, last lesson. We have very similar vocabularies today. So let's see what more points, special points we could identify in triangles. Critique and explain. Aisha wrote the following explanation of the relationships in the triangle. She said, I can see that angles TVY is congruent to YVU, okay, so these two, and VUX is congruent to XUT. UTZ is congruent to ZTV because lines TZ, VY, and UX bisect the sides opposite each vertex. By the concurrency of angle bisectors theorem, lines VY, UX, and TZ are concurrent. Can you say that? Is there anything that might be wrong? Because part A asks you, why is her explanation not correct? There's something wrong about it. Where is the unreasonable argument? First of all, what are we given? We have the same measurements for each side. So we know that these are bisected. The lines are bisected. Do we know that the angles are bisected? Not necessarily. These lines that bisect the lines don't necessarily bisect the angles. And she assumed that they do. But you can't really say that unless it's given. So basically, she assumed that lines TZ, UX, and VY were angle bisectors, but they're actually not. You can't really tell. What can you do in the future to avoid her mistake? Okay, you can study more definitions of the special segments in the triangle and how to identify those segments using the information in the diagram. So perpendicular bisectors, angle bisectors are different. And also these lines that we just looked at are called medians. And we'll look at those lines as well. And these are different. What makes them different? We'll see. But basically, you need to be able to learn and study and identify to avoid this mistake. Let's write that down. Okay, so we'll learn the definitions of special segments in a triangle and how to identify them. So we'll think about what are the properties of the medians in a triangle, what are the properties of the altitudes in a triangle. Example 1, identify special segments in triangles. What are the altitude and median that are shown in triangle ABC? What is an altitude and median? An altitude is a perpendicular segment from a vertex of a triangle to the line containing the side opposite the vertex. A median of a triangle is a segment that has endpoints at a vertex and the midpoint of the side opposite the vertex. Very important. Okay, so what are their properties? If you look at the diagram, it's easier to identify. The altitude is perpendicular to this DC, line DC. It has this perpendicular part is very important. It needs to be perpendicular. So altitude many times is equivalent to the height of the triangle. Okay, median would be the endpoint at one vertex and the midpoint. So altitude and median, they both have 1 point on a vertex, but an altitude is perpendicular to the opposite side. And then a median would be has a midpoint on the opposite side. So looking at this triangle, use the figure. What are the altitude and median that are shown in triangle ABC? We got some lines over here, CE and DB. What is the altitude and which one is median? Can you tell? If you look at this angle, that's perpendicular. So by definition, CE is the altitude. CE is the altitude. And DB, let's do BD. BD is the median because it's the D is the midpoint. So one vertex to a midpoint is a median. 1 point, one vertex to a perpendicular, 1 point that makes a line perpendicular to the opposite side is altitude. Part B, copy the triangle and draw the other altitudes and medians of the triangle. Copy the triangle now. Copy the triangle A, B, and C. And you should be able to draw a triangle that looks like this, okay? So this one, CE and DB is the one we already had, but if you draw an altitude from point A, AJ, actually, I want to pull this here. I can draw. So AJ is going to be the altitude, and AF is the median. And if we start from point, what didn't we have? Wait, let's label the one we had as well. BD was the median, and CE was the altitude. And so what about BH? BH is the altitude because it's perpendicular, right? And then CG would be the median because it's not perpendicular, but it looks like it's the bisector. Okay. Oh, I didn't realize that my share was paused. So here, so yeah, so BD is median, CE is altitude. You should draw the other 4 lines that are the rest of altitude and medians. AJ is altitude, AF is median, BH is altitude, CG is median. Okay, going back to our textbook. Theorem 5-7 is about concurrency of medians. The medians, it says that the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Whoa, what does that mean? So now that you know how to draw altitudes and medians, we have a special property for concurrency of medians. So this point of intersection for the medians. What was the median again? It's the line that connects one vertex to the midpoint of the opposite side. Okay, so all these medians meet at one point. And what does that do? It is 2/3. Medians of a triangle are concurrent at a point that's 2/3 of the distance from each vertex to the midpoint of the opposite sides. So from C to F, G is on the 2/3 of the distance from C to F. Okay, from A to D. So it needs to be from vertex to the midpoint. Okay, from A to D, G is 2/3. From B to E, G is 2/3. Okay. If you think of it the other way, from the midpoint to the vertex, G should be then 1/3 of the distance. Does that make sense? So example 2, find the length of a median. What is the length of JN in the figure? We know that JQ is 18, right? And we know by the concurrency of median theorem that 18 is 2/3 of this whole distance. Does that help? You can use the concurrency of medians theorem. Oh, we're trying to find JN, right? So you want to find JN, and JN, the 2/3 of JN should be 18, right? So then you can multiply the reciprocal of 2/3, which is 3/2 on both sides. And have JN is equal to 9 times 3, 27. So JN is 27. Use the concurrency of medians theorem. Look at try number 2. Find AD for each triangle using the concurrency of triangle theorem, of medians theorem. Okay, see if you can do it by yourself. Come back when you're ready for answers. So AD is a median, and you have an information that AE is 21. And by the concurrency of median theorem, we know that that's 2/3 of AD, right? So AD is 2/3 of AD is AE. And we know what AE is, 21. So AD is 21 times 3/2, which is going to be 63/2, which is 31.5. So AD is 31.5 for part A. What about part B? We know that DE is 12, and that's 1/3. So we can just multiply by 3. But how do we write an equation? We know that 2/3 AD is equal to AE, and we know that ED, we need to write an equation for ED then. We know that 1/3 of AD is ED. So 1/3 of AD is 12. So AD is 12 times 3/1, which is 12 times 3. And that's 36. So AD is 36 for part B. Okay. Example 3, locate the centroid. What is a centroid? We'll see. An artist wants to balance a triangular piece of wood at a single point so that triangle is parallel to the ground. Where should he balance the triangle? Ooh. He wants to balance a triangular piece of wood at a single point so that the triangle is parallel to the ground. The triangle is balanced at its center of gravity, which is at the centroid of the triangle. Okay, so centroid is the center of gravity. Isn't that cool? Do you know how Do you want to know how to make centroid? So step 1, you find the midpoint of each side. Step 2, draw a median from each midpoint. Label the centroid point Q. So the point of concurrency for medians are called the centroid. Now you know what they're called. So the artist should balance the triangle at point Q. So number 3, copy the triangle shown. Use the medians of the triangle to locate the centroid. And you're going to use the ruler to verify the centroid is 2/3 the distance from each vertex to the midpoint of the opposite side. So first, copy it down and try to verify using a ruler if it really is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, so if you are ready to check answers, I'll show you the triangle that you're supposed to construct. There's a centroid at point P over here. And if you use a ruler to measure them, it must have point P exactly at 2/3 from each vertex to the midpoint. Okay, theorem 5-8, concurrency of altitudes. The lines that contain the altitudes of a triangle are concurrent. Okay, so now what do altitudes do? Altitudes, remember, are the perpendicular lines from a vertex to the opposite side. And the lines that contain the altitudes of a triangle are concurrent. What does concurrent mean? Look at this figure. K, Q, L, N, and P are concurrent at X. It means that they intersect at one point. Okay, so that point might not be, might not have a proportion, but that's okay. Altitude, you just need to know that altitudes concur at one point, and that's enough. Example 4, locate the orthocenter, and guess what the point is called? The point of concurrency of altitudes is called the orthocenter. The orthocenter is the point of concurrency of the lines containing the altitudes of triangle. How does the type of triangle, obtuse, acute, right, relate to the location of its orthocenter? Remember, we kind of did a similar experiment for the centroids. Look at orthocenter. So if you look at obtuse triangles, the orthocenter is located outside a triangle. Acute triangles inside. And the right triangle, orthocenter is located exactly on the triangle. That's very similar to what we've looked at before, right? So, but orthocenter is a different from perpendicular bisectors. Orthocenters are just perpendicular lines to the opposite sides. Doesn't have to bisect the angle or the line. Okay, the orthocenter is outside an obtuse triangle, inside a acute triangle. For a right angle, it's at the vertex, and that's the only different thing. The orthocenter is located at the vertex, not on the side, but on the vertex of the right triangle. So let's try number 4. What is the relationship between an isosceles triangle, where the two sides are equal, and the location of its orthocenter? So draw an isosceles triangle, or maybe this, okay, where two sides are equal. And draw orthocenters by drawing altitudes. Okay, from one vertex to the opposite side, it must be perpendicular. Must be perpendicular. Must be perpendicular. So over here. So where is it located? Will be inside Would there be another case? Isosceles triangle. This could also be an isosceles triangle, right? So over here, and then it could be over here, could be so if the isosceles triangle looks like this, it's an obtuse triangle, right? But the orthocenter is going to be located outside. And believe it or not, there's an acute triangle for a right triangle. So that's also going to have the right triangle where the orthocenter is at the vertex of the right triangle. So an isosceles triangle has all of them because isosceles triangle basically could be both, could be all obtuse, acute, and a right triangle. Okay, so there are 3 cases. Or let's say obtuse triangle could be all of the triangles. Sorry, isosceles triangle could be all 3 cases, an isosceles obtuse triangle, an isosceles acute triangle, and an isosceles right triangle. So the orthocenter will be inside, on, or outside the isosceles triangle, depending on whether it is acute, right, or obtuse. Okay, so example 5. Let's find the orthocenter of a triangle using the coordinate points. Orthocenters can be found using constructions or coordinate geometry. Where's the orthocenter of triangle KLM? Since the orthocenter is the point of concurrency of the altitudes, you can find the equations for 2 altitudes and solve for the point of intersection. So first of all, you need to find the slopes of 2 sides of the triangle so that you can find the perpendicular line. Okay, slope of KL is 1/2, or you can count. Go 1 up over 2, 1 up over 2, 1 up over 2, right? So that's the slope. And the slope of LM is -1. You're going to use the point slope form to write the equations or of the altitudes perpendicular to KL and LM because you know a point and you know the slope that must be perpendicular, right? So equation of the altitude perpendicular to KL must be, you can use the point 3,12. That's your vertex, right? To draw an altitude that's perpendicular to this line KL. So your slope must be perpendicular slope from KL, which is the opposite reciprocal, remember from algebra 1. So -2/1 is your opposite reciprocal of 1/2, and that is your perpendicular slope for KL. So you plug in your slope here, your x value of the point here, y value of the point here. So you're plugging in m is equal to -1/2, and your point 3,12, that's your x sub 1, that's your y sub 1, okay? And then change that to slope-intercept form, that's your line equation. So equation of the altitude perpendicular to KL is y equals -2x plus 18. And in the same way, perpendicular to LM should be y equals x. And then you can solve the system of equations to determine the coordinates of the pointer intersection. If you figure out the solution of these 2 equations, remember, that's the intersection point of 2 lines. So that's, by definition, is going to be your orthocenter in coordinate geometry. So let the equations be equal to each other. -2x plus 18 must be x. And then you can solve for x and then solve for y. Or in this case, they substituted y in the equation and then solve for y. And then solve for x. Either way, you have different methods. But anyway, you should get the same point, 6,6. Let's try number 5. If you can find the orthocenter of a triangle with vertices at each of the following sets of coordinates. You have 3 points given. You can figure out the slopes first of any 2 lines. You can pick. It doesn't matter. And then, but you have to choose the vertex that's opposite of the lines you chose to figure out the equations. See if you can do it by yourself and come back for answer when you're ready. Okay, let's say that's point A, and that's point B, and that's point C. In order to find the slope of line AB, you're gonna use the slope equation, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 4 minus 0 over 10 minus 0 is 4 over 10, which is also 2 over 5, okay? And then the point that's opposite of AB would be C, right? So your first altitude starting from the vertex C would have the point A, 9, and the slope perpendicular to 2 over 5 is negative 5 over 2, right? So then you're gonna use this point slope formula, y minus y sub 1, which is 9, and then your perpendicular slope times x minus x sub 1, 8, and then change that to slope intercept form. Y is equal to negative 5 over 2x plus 20, and then you add 9 on both sides, right? And then so that's going to be y equals negative 5 over 2x plus 29 if you simplify the equation, okay? And then that's not the answer yet. And then you need to figure out another altitude. You can figure out slope of AC because A is easy. If you have a point A, it's easy to find a slope because A is basically 0, 0. So that's going to be 9 minus 0 over 8 minus 0, so it's 9 over 8. So perpendicular slope would be negative 8 over 9. Don't forget your negatives. And the point opposite to this line would be B. So you do the same thing, y minus b, the y value of point B is 4. And then perpendicular slope, negative 8 over 9. X minus 10. And then simplify. Y is equal to, add 4 on both sides, but you're going to use distributive property, 8 over 9, x plus 80 over 9. Okay, and then plus 4. So y is equal to negative 8 over 9x. And should we use decimals? Is it easy? No. So I'm just gonna change that 4 to 36 over 9 and add 36 from 80. That's gonna be 116 over 9. Okay. And using these two equations, you can figure out the intersecting point by setting them equal to each other. Negative 8 over 9x plus 116 over 9 is equal to negative 5 over 2x plus 29. Oh, those are some big numbers, but that's okay. You can do it. So why don't we add 8 over 9 over here? So negative 5 over 2x plus 8 over 9x. And then I'm going to subtract 29 from here. So 116 minus 29. What's 29 in terms of 9? 261. Oh, 261 minus 116 would be 140, negative 145 over 9 is equal to negative 45 over 18x plus, I'm trying to match the denominator. 16 over 18x. And then 16 minus 45 is going to be 145. Negative 145, right? So negative, wait, no. 16 minus 45 is negative 29. Negative 29 over 18x is equal to negative 145 over 9. So x is negative 145 over 9 times negative 18 over 29. And you can simplify that by 2. Can we simplify 145 by 29? Yes. 29 times 5 is 145. Ooh, so that becomes a pretty whole number, thank goodness, negative 10. So if x is negative 10, you can plug that into any equation over here. Negative 5 over 2 times 10 plus 29 would be negative 25 plus 29, which is 29 minus 25. And that's going to be positive 4. So that's going to be negative 10, comma, wait, it's not negative 10, it's positive 10, sorry, because negative times negative is positive. So positive 10, and if you plug that in here, y is equal to negative 5 over 2 times 10 plus 29, negative 25. And so that's going to be 4. So you have 10 comma 4 as your orthocenter finally. So it is a long process, but you can do it. Do it one by one. Okay, part B, if you have followed the process well, your orthocenter should be 15 comma negative 5. Okay, so figure out the slope of 2 points and then the perpendicular slope, and use the opposite point as a vertex and use the perpendicular slope to figure out the equation of the line of the altitude. And once you get to the equation of the line of altitudes, you need to figure out the intersection point of those 2 lines to get the orthocenter. Okay. All right. So that was the hardest tried ever in this topic. But if you know how to do that, great job, you've got it. Okay. If you don't know, if you need a review on Algebra 1, you might need to go back to the solutions of systems of equations and writing, finding the slopes of perpendicular lines. Okay, so that was lesson. That was already a lesson 3, medians and altitudes. So in this lesson, we learned that medians concur at a point centroid called centroid, and it is 2/3 the distance from the vertex to the midpoint of the other side. Altitude concurs at the point called orthocenter, and altitudes must start with a vertex to be a perpendicular, to make a perpendicular line to the opposite line. All right, so that was it. That was lesson 3 of topic 5, medians and altitudes. We'll continue with the inequalities in one triangle in the next lesson. Bye.